I'd like to show you a cool example of using an MCP-enabled domino. Here I'm going to show an example with my diabetes prediction machine learning project. We're going to work with a simple CSV dataset to train our classification model to predict diabetes with a simple set of features. Here you can see the diabetes model architecture, a simple four-layer neural net with hidden dimension sizes that are configurable. Our training script defines a typical training loop for this model and runs from the command line with arguments for setting typical parameters like number of epochs, batch size, learning rate, and the model size. I'm going to use a simple prompt to ask the model to understand our training script and optimize the model through a few training attempts. Because of cursor rule settings, the model will automatically run tasks on the Domino platform using the MCP server tools available to it. We're using Claude 3.7 thinking here, and it first reads the training script, the model architecture, and the Domino project settings. After verifying JIT is synchronized between our IDE and Domino, it runs a Domino job with a first training attempt. 10 epochs, 32 batch size, a small model, and 0.001 learning rate. After checking that the job is completed, it retrieves the results, and here you can see that it sees we've achieved a decent accuracy of 96%. It also opens a web browser showing the specific experiment run that was logged on Domino from this training attempt. While we're on the Domino UI, we can see here that Cursor ran the training like any other Domino job, meaning it's tracked and fully reproducible by any project collaborators. Okay, so Cursor has decided it's going to make another training attempt. This time, slightly more epochs, a bigger model, and reduced learning rate. I've zoomed in to show you we're getting a higher accuracy on this second attempt. But what's cooler is that Cursor has decided it's worried about overfitting and is proposing to make a code change to the model architecture to increase the dropout rate slightly. After checking the results of this third run, Cursor has decided to make one last change to our model code, adding weight decay to our atom optimizer. Checking the results of this final Domino job run, Cursor is providing a nice summary about the training run attempts it's done, and has concluded the final attempt is a good enough model candidate at over 97%. Thanks for watching. I'm looking forward to seeing what the community is able to do, working with AI agents leveraging Domino's platform capabilities.